It's, I think we are live.
All right.
Let me just check real
Let me
quick.
get some background music on.
Background music for the long.
Non-copyrighted.
सही आ रही है आवाज भी एकदम. All right, we can start.
All right.
So today, as you all know,
Dude,
we
share
have.
screen.
Oh yeah, my bad. Okay. All right.
Shit.
Do you see this?
Tiring day. Tiring day. Yeah, clear. All clear.
Oh, clear.
All right.
Nice. So
Today
let me just
we
recap real
are.
quick. We have completed the first module, which is setting the stage completely. The live, there's the proof on the stream. You can go back and check that. Only the prims and property paths stream was deleted due to a shitty software called Riverside. But yeah, today we're gonna be quickly going through scene description blueprints. I've got my flight in an hour, and I'll probably be closing the stream in the next 40 minutes because I think my boarding will start. But yeah, let's speed run through scene description.
Okay.
Um, yeah, so let's get started. Do you want to add something before we get started?
No, I think we have covered most of the thing. Let's just focus on the thing that we are going to cover today
Hmm.
because we are short on time.
Cool.
Scene description blueprints. Now that we have understand the USD fundamental building block, it's time to learn the essential schemas, the blueprints that give meaning. Wait, did you say something? Give meaning and capabilities to your prem. In this module, we will learn about how we can discover USD's built-in schema to create. Dude, okay, let's. Yeah, no. I can. Just give me. Okay.
Essential schemas. Okay, so these are the
Yeah.
schemas. A schema is an object that provides structured API for authoring and retrieving data from prim and properties. Cool. The blueprint, okay, authoring and
Uh,
retrieving data from prim and properties.
mhm.
Okay, the blueprint that give meaning and capabilities to your prims. In this module, you will discover how to use USD's built-in schemas to create the core elements of any 3D scene. What you'll learn by the end of this module, you'll be able to define USD schemas, understand how is a, okay, and is a schema defines, okay, okay, and is a schema defines what type of thing a prim fundamentally is, okay, determining its core identity and built-in properties. Cool. And API schemas define what prims are and what they can do. Organize scenes and scopes and XForms. Okay. So this is what we have been getting confused with all this time. So I think now they're going to cover it in detail. Use these
Yeah.
organizational containers to structure complex hierarchies. Simplify transform with XForm common API. Use the streamlined API for common transformation workflows. Apply lighting schemas. Work with USD Lux schema domain to light your scene. Okay. Why this matters? These schemas provide the standardized building blocks that ensure your content works across different applications and pipelines. A prim without a schema is just an empty container. With the right schema, it becomes a light, a transform, or a piece of geometry that other applications can understand and work with. Cool. After we cover essential schemas, you'll be ready to explore USD's powerful composition system, where you'll learn to combine layer these building blocks into complex collaborative scenes. Okay, so we have completed the overview. It was nothing too crazy. So now we are moving on to schemas. Okay,
Mm-hmm.
schemas give meaning. What the hell? Give meaning to objects in OpenUSD. Okay, they give meaning to objects in OpenUSD. Blueprints that author and retrieve data provide a consistent and extensible way to define and interpret data. Okay, ensure data interoperability between different software tools and applications. Correct, like Houdini or Hydra or Omniverse. Okay, so that was done. Um, Schemas give meaning to prims in OpenUSD. That is, what is this element? What capabilities does it have? Schemas define the data models and optional API for encoding and interchanging 3D and non 3D concepts through OpenUSD. Cool. We'll explore a different type. We'll explore the different types of schemas, their characteristics, and how they enable the creation of sophisticated virtual worlds and digital twins. Cool. Schemas serve as blueprints that author and retrieve data like attributes and relationships that govern behaviors of elements in a USD scene. Each prim in a scene and element that implicitly contains the properties and fallback values of the typed schema that's telling the prim what it
What
is.
is, for
Okay.
for example, radius attribute for the sphere schema is defined as double radius,
Hmm.
meaning that all the sphere prims have a radius represented by double precision floating point number with a value of 1 by default. Right, so this is what we read in the earlier sections where it was said that an attribute can only have a single data type. So over here, since we are defining a sphere, it has a radius and the data type is a double float data type. And the default value is 1. So if we are defining something using like a sphere or something and we do not define the value, the value defaults to 1 for that attribute. If it's a double radius or something,
Hmm.
schemas are primarily data models with documented rules on how the data should be interpreted. While schemas define the structure and rules, they do not necessarily include the implementation of behavior. For example, the USD physics schema doesn't come with a physics engine. The developers may provide behaviors in the schema API, but this is not a requirement. Okay. Hmm. So it says that rule on
They are
data.
primarily data models with documented rules on how data should be interpreted.
Okay. So
So while
usually they have a definition, but sometimes they won't come with those definitions.
Mhm.
That and one of the example is USD physics. It should it should come with a physics engine, but it does not, and that is not a requirement. That's what it's saying.
yeah,
Then there is a trend toward codeless schemas for easier distribution, suggesting that schemas might become more lightweight, focusing on data modeling
mhm.
rather than behavior implementation.
Okay.
And actual behavior enforcement can be merged by other subsystems within the runtime ecosystem. This allows for flexibility and performance optimization based on
Wait.
different use
What
cases.
does this mean? This there is a
This,
trend toward codeless schemas for easier distribution, suggesting that schemas might become more lightweight. Okay. Focusing on data modeling rather than behavior implementation. Data
yeah,
modeling rather than I
they
think.
won't be used. So like I think the what the industry is trying to do is rather
And is
to
this are these data models going to be stored in the database or something?
I don't think so. So the data modeling is some kind of a parenting model or a data
Yeah.
definition
Hmm.
that you have with the schema. It's not about like you are going to store it somewhere, but it is a type that hey, if you are basically if you are generating a sphere, it would have a predefined data model that is the radius is always double or the or something else is over there like the mesh or something is always will always have certain type of definite values. I'm assuming over here.
Okay.
And The next is the actual behavior enforcement that can be managed by other systems within the runtime ecosystem. So I think this is what they are talking about. Like for example, in the schema, if you don't want to use its own physics engine, right, you can you can basically pull some other systems runtime ecosystem or maybe the physics engine that will allow for flexibility and performance optimization based on like the different use cases. And then
Okay.
there are two types of schemas over here. One is ISA schemas. So an
Is is
is a and as a schema defines what type of thing a prim fundamentally is, determining its core identity and built-in property. And then we have API schemas. So an API schema provides a collection of related properties and methods that can be applied to prims to add specific functionality. So this is what so this is these are the two main types of schemas that are necessary for schema definition as we have learned. So let me just recap what is a schema. So and is a schema defined that a prim is fundamentally determined by its core identity and built-in properties. Whereas API schemas, they provide a collection of related properties. So it's not like code or something, but it's like relatable that hey, these are the properties that might exist for these APIs. For example, an API schema could be XForm or something. Now, moving on to is a schema. Is a schema are also known as typed schema. So I think they are more type scripted or prim schema. Essentially tell a prim what it is because of this each prim can only subscribe to one is a schema at a time. Hmm. We use the type name metadata to assign us is a schema to a prim. Okay, so this is how we will define if we want to set is a schema to a prim. We have to make sure to use type name, otherwise it won't we won't be able to define that that prim has a is a schema. And is a schema is derived from a class called USD type. So this is the class from where is a schema is derived. As we learned earlier in our last stream that USD has different kind of modules and classes. So one of the class that comes from the base class USD is the USD type over here. The base class for all type schema, which is why we here is a schema referred to as typed schemas. So I think what I have understood till now is if we put it into a computer science or a full stack engineer analogy, we have TypeScript and we have JavaScript. So TypeScript is more, how would I say, strict language that you have to define each and every variable. You cannot put that, hey, for example, if you're defining a variable X, you need to define what type of variable it is. Is it a number? Is it going to be a string? Is it going to be a boolean? In that matter, so in that scenario, we don't miss out any variables or maybe do a buffer overflow. These schemas can either be concrete, instantiable, or abstract. That is non-concrete, serve as base classes. We refer to a schema as concrete when the schema can be instantiated as prims in the USD scenes. As we see with USD Geom Mesh and USD Geom Scope, so these are the other library, other modules that we have in our USD that we are talking about over here. These are like concrete schemas that provide both a name and a type name in the schema definition. Meanwhile, abstract or non-concrete schemas provide a name but no type name in the schema definition. This enables them to serve a base class for related sets of concrete schema. The way USD geom point base serves as a base class for geometric objects that contain points like meshes or basic curves, that is USD geom basic curves. So all in all, these schemas can be either concrete or abstract, serve as a base class.
wait. We use type name metadata to assign as a schema. As a schema is derived from the core class USD type. The base class for all type schemas. The base class for all type schemas, which is why we here is a schema referred to as typed schemas. Okay. These schemas can either be concrete, instantiable, or abstract, non-concrete, serve as base classes. Okay, we refer to a schema as concrete when the schema can be instantiated on prims in USD scene. Instantiated on as prims, so they are concrete. When we
Yeah.
use like something like USD geom mesh and USD geom scope. Okay, and concrete schemas both provide name and a type name in schema definition. Okay, meanwhile, abstract or non-concrete schemas provide a name but no type name. Okay, they provide a name but no type name. Okay. No type name. Okay? I think I understand. I think let me see if I have. Mm, I lost my notebook. Oh, here it is. Mm, mm. So you see over here, like this is an abstract schema because this has no type,
Yes.
right?
Yep.
But at the same time, I think this would be a concrete schema because it has a type sphere. You see,
Hmm. Wow, makes sense. Makes sense. Hmm.
this is the type and this is the prim.
You are saying that the looks is a non is an abstract scheme over there. Def
Yeah,
looks and def material. Okay.
yeah.
Okay.
Because you see, provide a name but no type name in schema definition. So this is the schema definition
Mm-hmm.
over here, but there is no type name, which means it is a abstract schema. And like we have seen for let me see, so over here. So you see, we have the schema X form over here because we are using USD dot stage dot open define prim, and this is the path and this is the type. So X form is the type of the schema.
Mm-hmm.
Where did we use USD X form? Okay, whatever. But yeah, I think I understand this a little bit.
Mm-hmm.
Is
Maybe
a
if you want
schema are derived from a core class USD type, the basic class for all typed schemas. So this is what we were doing yesterday
to, yeah.
over here in modules. Wait, bro, 1 second. I think my boarding.
I started.
No, I don't think so.
At what
Already.
time is it? You know,
What?
at what time it was supposed?
My
It's
fl-
7:45, right?
my flight is at 7:50, so I'm guessing the boarding will start at
At 7:30.
7:25 or 30.
Yeah, we still have half an hour where you can go.
Yeah. Okay, we can keep reading. Um, do you want me to ask Gemini to like make this
Yeah,
easier?
definitely. For sure, for sure. Or maybe we could ask Lord Code, right?
I'm not opening Cloud Code right now, bro. I have a lot of things open and I don't have multiple monitors. I just have one laptop screen. So we understand this. Can you hear the noise behind me or is it getting cancelled?
Yeah, I can hear a baby crying or
Yeah.
something.
Damn.
Noise cancellation is not at the best right now.
This part of OpenUSD documentation explain identity of objects in 3D scenes. To make this simple, let's use kitchen appliance analogy. Bro, can you read this? Can you see my screen? Like, or should I make it more?
Wait, all right. So
I want to
codeless
start
schema.
eating, bro.
The text-based schemas are becoming codeless and focus on data rather than behavior. The analogy: imagine you buy a toaster old way. The toaster the, comes with a built-in computer that only knows how to toast bread. Codeless way, the toaster is just a box with a heating element and a label that says I am a toaster. You don't build the toasting logic into the box itself. Instead, you have a smart home system, the running ecosystem that reads the label and says, "Oh, a toaster! I know how to turn that on." Why? It's easier to ship just the box and let the different smart home systems decide how to handle this. That is what codeless schema means over here. And then if we take a look at the ISS schemas, the what is it rules. ISS schema are also called typed schemas. Tell an object exactly what it is. The rule: an object can only be one thing at a time. Analogy: an appliance can be a toaster or it can be a blender, but it cannot be both. And this is object core identity. The text mentions concrete and abstract schemas. This is the difference between
Okay.
you can actually touch and a general idea. These are the real things that you can put in your scene. A concrete, a sports lock toaster, you can buy it, put it on your counter, the stage, and use it. Scroll down and more, bro. Abstract, non-concrete, these
Bro, did
are
you
the
read this?
categories. Yeah, I did read that. Get it.
Wait, an appliance can be a toaster or it can be a blender, but it cannot be both in the same body. This is the object's core identity. Okay. So like sphere is a schema, right? I is a schema.
Yeah.
Also called typed schemas. Okay.
And then we have abstract, non-concrete. These are the categories that don't exist in real life, but help organize the real things. Analogy: heat appliances. You can't go to a store and buy a general heating appliance. You have to buy a toaster or an oven, but both toasters and ovens share the heating element. Example: usage beyond point base. You can't make a point based object, but it acts as the parent for the things that do points like meshes or curves.
Okay.
So I think we have covered API schemas of both the type of API schema that no, no, like types of schemas that exist till now, and the next is a video as you can see talking
One
about.
second. One second. Mm, Okay.
So in Python, we can work with schemas with the following methods. We are using the base library USD and then calling a module or so that is schema registry and then a function
Mm-hmm.
that is calling schema info. So this will help us get drive the schema info for a registered schema.
Mm-hmm.
And similarly, we have again a base USD library that we are using, and then we are calling the module schema registry, and we are using get schema type name to get the type name for that schema. These methods allow us to interact with and manipulate schemas programmatically, enabling us to create, modify, and validate USD assets. A name resource, often version that is maintained, used, example layers, texture, volumes, etc., based on
Oh, my
predefined
boarding has started.
convention. Okay, alright then.
Yeah, I think I need to pack up now. Well, my
Okay.
boarding has zone one has started.
Yeah.
I think
So I
I
think
am.
I'll tell this one, like
Yeah, yeah,
the
yeah.
alright. So these are all the this is how we can use the USD library and the schema registry module to get the information, retrieve information for the schema and the schema type.
Okay, I'm zone eight. So
We
boarding
have to
zone two
roll.
right now.
Oh,
Yeah, but I only have like 5 minutes.
okay, okay. So do you want to go ahead or what do you want to do now? Like because
Uh,
it's a lot. Like we cannot walk through in 5 minutes for sure.
okay, let me do a speed run over here. So
Yeah.
retrieve the schema info for registered schema, usd.schema registry, find schema info. So this is used to retrieve the registered schema. This is used to retrieve the schema type name. Okay. Is the schema USD geom sphere? Okay, so this is a walkthrough of the code. We have to import USD geom sphere equals to USD geom dot sphere dot define stage. Yes, we have been using this sphere dot get radius attribute set temps, which is setting the radius to 10. Set the radius attribute of sphere to 10. Okay, schema USD lux importing. Disk light equals to USD lux dot light. USD lux dot disk light dot define stage. Okay, so that is defining the light layer. DL distribute, okay, over here. US Deluxe defines the schema representing light sources in the scene. It includes schemas such as sphere, light disk, lights, and distant lights, which were discussed in the lesson on USD lights. Examples include USD Lux light, reflect light, the sphere light. These schemas bring properties relevant to each type. Okay, okay. This is how we define the disk light. USD Lux dot disk light dot define, the same as we define the stage or something like that or trim.
Yeah.
This is how we are doing or getting all the attribute names that are part of disk light and
Mm-hmm.
set the radius and intensity of the disk light by doing dot set on get radius attribute and get intensity attribute. Okay, and then USD physics rigid. Okay, so this is the physics one. We are using rigid body API dot apply.
This
in
is
the same.
more of a normal API. That is the most important thing. This is a
Mhm.
more of a normal API, like
All right, bro. I think I
non-standard.
need to go.
Guys, that was a quick intro into the schemas. We will get.
Yeah, we'll do some little bit of revision in the next one as well. But
Oh
yeah,
yeah, yeah. We will
all
walk.
right.
We will definitely go through this again. Next
Hmm.
probably tomorrow, right? Same
Tomorrow,
time.
correct. I don't
Yeah.
know though about the time right now, but probably.
I was same time.
Yeah. All right, bros. Later.
Yeah.
चल भाई. Okay.
हो गया? चल,
कर दिया मैंने.
भाई।
Hmm.
हम्म।